Hi everyone, so today's lesson is going to be on continuously compounded interest. The first thing we want to do is go over our homework from yesterday. So in the first problem, I gave you ln of 7,331.9 is equal to 8.9. What we had to do was convert this into exponential form. If you remember from yesterday, I told you anytime you see ln, we can replace that with log base e. And anytime we see log base e, we can replace that with ln. The two can be used interchangeably. So ln is equal to log base e. So the first thing we're going to do is replace it. So now we're left with log base e of 7,331.9 is equal to 8.9. Okay, if we remember, base, answer, exponent. So now I'm going to write this into exponential form. So e to the 8.9 is equal to 7,331.9. This right here is your final answer. This is now in exponential form. This one, we have to solve for x. So we have ln of 6 is equal to x. For this one, it's not so much. All we got to do is we got to just, on our calculator, we're going to hit the ln button, put in 6, and hit enter, and it's going to give us a long number. We're going to round it to 2 decimal places, so our answer is 1.79. So how about this one? Solve for x. E to the x is equal to 105. The first thing I would do here is put this into log form. So remember, base, exponent, answer. Log form goes base, answer, exponent. So here we have log base e of 105 is equal to x. Well, if we remember, I told you log base e is equal to ln. So now we're left with ln of 105 is equal to x. Now all we have to do is hit the ln button, type in 105 on our calculator, hit enter, and we find our x is equal to 4.65. How about this one? Solve for x. E to the x is equal to 40. So the first thing, convert it into log form. So log base e of 40 is equal to x. Log base e is equal to ln, so now we're left with ln of 40 is equal to x. Type in ln of 40 in our calculator, and we get x is equal to 3.69. How about this one? ln of 98.4. All we're going to do is type in ln 98.4 in our calculator, and then we get 4.59 as our final answer. How about this one? ln of 1023. Same thing. Type in ln of 1023, and we find out our answer is 6.93. How about this one? ln of negative 45. Okay, so some of us, my calculator, it comes up non-real answer or non-real solution. So all that means is no solution. Some of our calculators are going to come up with an error message. If you get an error message, a no solution message, that just means we have no solution. So today's lesson, we've previously learned about compound interest. As a reminder, here's what compound interest look like. So I tell you, $1,000 is invested at 1% compounded semi-annually for 10 years. What's the amount at the end of 10 years? And then what's the interest earned? Well, for that one, our formula is going to be AT is equal to P times 1 plus R over N times NT. Our P, which is our principal, is equal to 1,000. Our rate is equal to 1%, and remember we have to convert that to a decimal, so it's 0.01. Our number of compounds is 2 because it's semi-annually, and our T is 10. Next, what we're going to do is plug all of that into the formula. So now we're left with 1,000 times 1 plus 0.01 over 2 times 2 to the 10th. And if you remember, what I told you to do first was simplify 2 times 10 and we get 20. Then we're going to do, just rewrite it as 20 up over here. Then what we're going to do is 0.01 divided by 2. Once you get the answer, add 1 to it, and then do whatever that answer is, raise that to the 20th power. Then from there, we're going to multiply that by 1,000. So at the end, we should have $1,485.95 as our final answer. Now this is the amount after 10 years. Now in the question, I also asked you how much interest was earned. So all we're going to do is take this number and subtract it from the initial investment, which was 1,000. So at the end of 10 years, the amount of interest we earned is $485.95. So now let's cover continuously compounded interest. So when you see the word continuously, we're going to have a completely separate formula for this one. So anytime in any word problem, if you see the word continuously, we're going to use this formula. A is equal to P times E to the RT. Some of you who have taken the business class at PC might have heard the PERT formula. This is the formula for continuously compounded interest. So once again, A is the amount at the end. P is our principal, which is our amount initially invested. Our E is just going to be the button on our calculator. Our R is our rate as a decimal, and our T is time. So remember I told you our R has to be a decimal. How do we convert a percentage to a decimal? Well, as a little reminder, there's 2 ways to do it. The first way, you could put the percentage over 100. We could do this, but if we don't put parentheses in our calculator, it kind of like spazzes the calculator out. Or the way that I do it, so way number 2. You just move the decimal point 2 places to the left. So the first problem, $1,000 is invested at 12% for 3 years, continuously compounded. What's the ending amount? So our principal is 1,000. Our R is 12%. As a decimal, it's 0.12. And our T is 3. We're going to use PERT formula Y because it's continuously compounded. So we're just going to go and plug in P, R, and T. So our P is 1,000, our R is 0.12, and our T is 3. So now we're going to do, I would simplify this first. So we're going to simplify 0.12 times 3, and we get 0.36. Now the next step I would do is I would simplify this first. I would do E to the 0.36 power. When we do that, I get 1.433. From this point on, I am now going to multiply this times 1,000. And when I do that, I get 1,433. So if we invest $1,000 initially at 12%, continuously compounded for 3 years, at the end of 3 years, we'll have $1,433. So how about now if we invest $25,000? It's invested at 8% for 5 years, continuously compounded. What's the ending amount? Well, our principal is $25,000. Our R is 8%, which is equal to 0.08. And our T, which is our time, is 5 years. So we're going to use the continuously compounding formula. And we just plug in. P is 25,000. Our R is 0.08 and our T is 5. So first things first, we multiply 0.08 times 5 and we get 0.4. Simplify this first. So E to the 0.4 power gives me 1.492. So I'm now going to multiply 1.492 times 25,000. And in the end, we should get $37,300. Now, here's what's important. Some of you guys, we might be a little off. Just make sure you're showing me where you're rounding. This right here would be the most important, crucial step in where to round. I would say at least go to 3 decimal places, if not more. Make sure you show me what number you're using here to multiply by the principal. If I don't know which you're multiplying by, our answers are going to slightly differ, and I'm not going to know where your answer is coming from. So it's important that you show me every single step along the way. Now, how about if we invest $950 million at 5% for 8 years? It's continuously compounded. What's the ending amount? So our principal is $950 million. Our R is 5%, which is equal to 0.05. And our T is 8. Still using PERT. As a little side note, make sure we convert our rate to a decimal. Some of you guys, I know, and when we did compounded interest, forgot to convert the percentage to the decimal. So we're using PERT, so we're going to fill in 950 million times e to the 0.05 times 8 power. Simplify 0.05 times 8, and we get 0.4. So the first thing I'm going to do is simplify e to the 0.4 power, and I get 1.492. Now I'm going to multiply 1.492 times 950 million, and I get $141,740,000,000. This is our ending amount at the end of 8 years at 5% interest rate. So how about now if we invest $10,350 at 3% continuously compounded? How much money will we have in 8 years? Principal is $10,350. Our rate is 3%, which is equal to 0.03, and our T is 8. Use our PERT formula. So now we have, just plug everything in. So my first thing I'm going to do is multiply 0.03 times 8, and I get 0.24. First thing, simplify this first. So I do e to the 0.24 power, and I get 1.271. Now I'm going to multiply 1.271 times 10,350. When I do that, I get $13,154.85. Some daily reminders for you guys. Your homework is assigned daily, and it's posted in Google Classroom and on Plus portals. Your homework is to be uploaded to Google Classroom or emailed to me before the start of class. If I don't receive it before, it's considered late and you don't receive full credit. On Friday, May 8th, you're going to have a quiz on the material we've covered so far this week. And on Tuesday, May 12th, your test packets are due to me. If you're not submitting them on time, you will be losing points if they're not submitted at the start of your class period. So here is our pet of the day. This right here, this is Griffey. This is Mr. Featherstone's dog. Griffey is named after the baseball player Ken Griffey Jr. Griffey is an English Labrador Retriever, and he's known for his great temperament. He has an otter-like tail, and he's a little boxier looking than the traditional American or field lab. Griffey loves his family, but he kind of wants everyone to leave because he wants to sleep on the leather couch in the downstairs den. Griffey loves to walk and swim. Running's not his favorite. Griffey can do many tricks, and he just wants to please the Featherstone family. So here is a little video from Griffey.
Hello, Miss Bogdan's class. This is Griffey. Griffey, can you get me the newspaper? Go ahead, go get it. Get the paper. Go ahead. Go ahead, go get it. Go get the paper. Hurry up. Get the paper. Good boy. Come on. you. Come on. Coming up the path. Ah, thank you, Griffey. Come on up here. Oh, thank you. Thank you, Griff.
What a great boy Griffey was. Hope you all enjoyed that little video. Have a great day, guys.